Imagine a sound so loud that it doesn't just hurt your ears. It vibrates the coffee in your cup, rattles the fillings in your teeth, and shakes the very foundation of your house like a minor earthquake. Now, imagine that sound isn't coming from a natural disaster, but from a machine running right through the heart of your neighborhood. In the history of American industry, we have built some truly terrifying things. We've built machines that are too heavy for bridges, machines that are too fast for human reflexes, and machines that leak toxic chemicals. Usually, when the government steps in to ban a piece of technology, it's because that technology is dangerous. It explodes, it kills people, it fails catastrophically. But in 1962, the city of Los Angeles did something that had never been done before and hasn't really been done since. And they issued a legal ban on a specific type of locomotive, Union Pacific's Pride and Joy, not because it was unsafe, not because it was prone to derailment, but simply because it was too much for the human senses to endure. It was a machine that solved a logistics problem by throwing so much raw power at it that the laws of physics and the patience of the public finally snapped. This is the story of the gas turbine-electric locomotive. It is the story of an era where American engineers looked at the jet engine, a technology designed to conquer the sky, and decided, in a fit of audacious madness, to bolt it to the ground. To understand why anyone would build a train that sounded like a 747 taking off in your backyard, you have to understand the desperation of the post-World War II world. We tend to look back at the 1950s as a golden age of stability, but for the American railroad, it was a time of absolute crisis. For 100 years, the steam engine had been king. These were the romantic giants of the rails, machines like the legendary Union Pacific Big Boy. They were massive, they were powerful, and they were beautiful. But they were also logistical nightmares. A steam engine is essentially a giant tea kettle that needs to be constantly fed coal and water. They required armies of maintenance workers, frequent stops, and massive infrastructure just to keep moving. By the end of the war, the railroads were done with steam. They wanted something new. They wanted efficiency. The answer, logically, was the diesel engine. But there was a problem. The diesel technology of the late 1940s and early 1950s was, to put it mildly, pathetic. If you look at the specs of a standard diesel locomotive from that era, it could barely scrape together 1,500 horsepower. That might sound like a lot for a truck, but for a train hauling 10,000 tons of freight, it was nothing. Union Pacific wasn't moving cargo across the flat plains of Kansas. They were fighting gravity in the Wasatch Mountains of Utah and the high deserts of Wyoming. These are some of the most punishing railroad grades on the planet. To get a heavy freight train over those peaks using early diesels, Union Pacific had to lash 4, 5, sometimes 6 locomotives together in a long chain. It was a mess. If one engine broke down, it dragged the others. The maintenance costs of keeping 6 engines running just to move one train were eating into their profits. They didn't want a pack of poodles to pull their sled. They wanted a wolf. They wanted a single machine with the brute force to conquer the mountains alone. And this is where General Electric enters the picture. GE had spent the entire Second World War building jet engines for the military. They had mastered the art of sucking in air, compressing it, mixing it with fuel, and igniting it to create massive thrust. As the war ended, their engineers looked at the struggling railroads and had a radical idea. They asked, "Why are we messing around with pistons and cylinders? Why don't we just use a jet engine?" Now, a gas turbine locomotive is a strange beast. It doesn't use the jet thrust to push the train forward like a rocket. That would burn the train cars behind it to a crisp. Instead, the jet engine spins a turbine shaft at incredible speeds. That shaft spins a massive generator, which creates electricity, and that electricity powers the motors on the wheels. It's a power plant on wheels. The result of this experiment was the big blow. Specifically, the third generation of these turbines, delivered in the late 1950s. When these things rolled out of the factory, they didn't look like trains. They looked like something from a science fiction magazine. They were nearly 180 feet long. They were so massive they had to be built in 3 separate sections. The front section held the crew and the controls. The middle section was the belly of the beast, housing the massive turbine engine itself. And the third section was a dedicated fuel tender, because this thing didn't just drink fuel, it drowned in it. But the number that mattered was the horsepower. These machines produced 8,500 horsepower. To put that in perspective, that was more than 5 times the power of a standard diesel locomotive of the time. It was, and remains, the most powerful internal combustion locomotive ever mass-produced. It was a monster. It could pull a train that was miles long up a mountain pass without breaking a sweat. But there was a catch. Actually, there were several catches. The first was the fuel. And this is really the secret sauce of the whole project. You see, jet engines are usually designed to run on refined kerosene or jet fuel. It's clean, it's light, and it burns hot. But jet fuel is expensive. Union Pacific couldn't afford to fill a freight train with high-grade aviation fuel, so they modified the turbine to run on something called Bunker C. Now, if you're not familiar with the oil industry, Bunker C is what's left over at the refinery after they've boiled off everything valuable. After they take the gasoline, the diesel, the kerosene, and the heating oil, the thick, black, tar-like sludge at the bottom of the barrel is Bunker C. It is practically industrial waste. At room temperature, it's so thick you could almost walk on it. It doesn't flow. To make this sludge usable, the locomotive's tender was essentially a giant thermos. It had heating coils inside it, running off a separate generator just to keep the fuel at 200 degrees Fahrenheit. If the heater failed and the fuel cooled down, it would harden into asphalt inside the tanks, bricking the entire locomotive. But here was the genius of the plan. Bunker C was dirt cheap. In the 1950s, our refineries would almost pay you to take it away. So, Union Pacific had a train that was 5 times more powerful than a diesel, running on fuel that cost pennies. On paper, it was the perfect economic machine. In reality, however, living with this machine was a different story entirely. Let's talk about the noise. A standard diesel engine makes a chugging sound, a low-frequency rumble that we are all used to. A gas turbine doesn't chug. It whines. It produces a high-pitched, piercing scream that sounds exactly like a jet fighter preparing for takeoff. The physics of this sound were punishing. The turbine blades were spinning at thousands of revolutions per minute. The air intake was sucking in so much atmosphere that it created a vacuum pressure around the locomotive. If you were a crew member assigned to a big blow, you knew you were in for a rough shift. The noise inside the cab was so deafening that the engineers and conductors couldn't speak to each other. They had to develop a complex system of hand signals just to communicate basic operations, trapped in a vibrating steel box for 12 hours at a time. The vibration wasn't just annoying, it was a low-frequency pressure wave that would rattle your bones. And then, there was the heat. The exhaust from a gas turbine is incredibly hot. We are talking about exhaust gases exiting the roof at nearly 850 degrees Fahrenheit. And unlike a piston engine that puffs exhaust, this was a continuous high-velocity jet stream of superheated air. There is a famous story from 1961 that has become legendary among railroad historians. It perfectly encapsulates the absurdity of this machine. A Union Pacific turbine was stopped at a red signal near Ogden, Utah. It happened to be idling directly underneath a highway overpass. Now, turbines don't idle well. They are designed to run at full power or not at all. Even at idle, the turbine is spinning furiously, blasting that invisible column of heat straight up. The crew sat there waiting for the light to change. Meanwhile, on the bridge above, drivers started to panic. Their cars were feeling sluggish. Then, people noticed that the road surface was changing. The exhaust was so intense that it hadn't just warmed the bridge, it had literally melted the asphalt. The road turned into liquid tar and began dripping down through the seams of the bridge, coating the pristine locomotive below in sticky black goo. They had built a train so powerful it could literally melt the infrastructure of the country it was traveling through. This brings us back to Los Angeles. Out in the wide-open deserts of Wyoming or the salt flats of Utah, nobody really cared about the noise. The coyotes and the sagebrush didn't file noise complaints. The massive plumes of black smoke from the Bunker C fuel would just dissipate into the big sky. But Union Pacific didn't just run in the desert. They ran into civilization. As these massive turbines approached the terminal in Los Angeles, they had to pass through miles of dense suburbs. And remember, the sound of the big blow wasn't just loud, it was pervasive. It was a physical force. Residents described it as a torture session. As the train approached, the low-frequency vibrations would penetrate the walls of houses, windows would rattle in their frames, dishes would dance across tables, babies would wake up screaming. And then came the high-pitched whine, a shriek that cut through everything. By 1962, the residents of the approach corridors into LA had reached their breaking point. They didn't just complain, they revolted. They flooded City Hall with angry letters, phone calls, and petitions. The pressure was so intense that the city government had no choice. They slapped Union Pacific with a ban. The most powerful locomotives in the world were effectively exiled from one of the biggest economic hubs in the world. They were banished to the desert run, forced to haul freight between Utah and Wyoming, far away from sensitive ears. It was a humiliating blow. But remarkably, it wasn't the ban that killed the program. The turbines continued to run in the desert for several more years. They were still powerful, and they were still cheap to run. So, what finally killed the big blow? It wasn't the noise, it wasn't the melted bridges, it wasn't the unhappy crews. It was plastic. You have to remember that the entire economic model of the turbine relied on that bunker C fuel being garbage. It was cheap because nobody wanted it. But as the 1960s progressed, the world changed. The chemical industry discovered cracking, a method to break down heavy oils into lighter, useful polymers. Suddenly, that thick, useless heavy oil wasn't useless anymore. It was the raw material for the plastic boom. It was the stuff that made Tupperware, polyester, vinyl, and consumer packaging. Almost overnight, the price of bunker C skyrocketed. The waste became gold. By 1967, the fuel that the turbines guzzled was just as expensive as regular diesel. The math collapsed instantly. The turbine engines were incredibly inefficient compared to diesels. They burned twice as much fuel to do the same work. The only reason they existed was that the fuel had been half the price. When that advantage vanished, all Union Pacific was left with was a fleet of loud, complicated, road-melting monsters that now cost a fortune to run. The writing was on the wall. By the late 1960s, Union Pacific began retiring the fleet. They were dragged into scrapyards, cut up, and melted down. The roar faded, replaced by the steady, boring, efficient hum of the modern diesel engine. Today, only a handful of these leviathans survive in museums. If you stand next to one, you are struck by the sheer scale of it. It feels less like a train and more like a rocket ship that lost its wings. The era of the gas turbine was a brief, thunderous flash in the pan. It lasted less than 20 years, but it stands as a fascinating monument to a specific moment in American history, a time of unapologetic industrial ambition. It was a time when we didn't care about noise or pollution or subtlety. We cared about power. We proved that we could build a jet engine on wheels. We proved we could haul a mountain of freight with a single machine. But in doing so, we also learned a valuable lesson, that sometimes the best solution isn't the one that screams the loudest. The big blow was the wrong solution. But my God, was it a magnificent failure.